So y is 100. Okay. Now, and I couldn't find that initially without knowing that 24, right? So it's nice to find a value, even though there wasn't a variable there. It is an unknown value that we can find because we have the facts to prove that that is indeed 24. Another set of angles that we're interested in are these down here at the bottom. So look at those parallel lines. Look at that transversal. Terrible. But again, what's the link between that green angle and that blue angle? Supplementary. Same side interior, right? So you knew initially that x was 56, right? So that's 80 again. So we got 80 plus 4z should equal 180. 4z should be 100. Z is 25. Okay. Now, what kind of give you a little prelude into what we're going to recognize later on is if this is 100, that's got to be 100. If this was 80, that's got to be 80. Okay? And that becomes a fact about that type of shape. What type of shape is that? Parallelogram. Okay? We will have a theorem, I think it's chapter 6. We'll have a theorem that says opposite angles in a parallelogram are congruent. And we'll go through and we'll prove that, and we'll figure out why. Well, it's all because of these alternate interior angles and same side interior angles. That's the logic that will always show opposite angles of parallelogram to be congruent. Okay, so I think it's important for us to, as we're using this stuff and first learning about it, to also see that it has a practical use later on within the course. Okay, so hopefully maybe that opens your eyes to how important it is now. Because if we struggle with it now, and that new stuff later on, chapter 5, chapter 6, we're going to struggle with that too. Okay. Give that one a shot. You got 4 or 5 minutes to do that. A little bit more good. All right, so we got a relation there we can see. Okay, transfer the 90 degrees over, transfer the 3x over. So you should have 3x is equal to what? 3x is equal to 90. Okay. Some people write, well, I know those two angles should be supplementary. Well, after the first step of algebra, don't you get to that? Okay. So x ends up being 30 regardless. Okay. So x is 30. That's nice. Okay. Now, again, if I struggle with the idea, struggle with the concept, you've done everything you can do with that transversal. See what you can do with that transversal. So I'm going to clone that, slide it over, get rid of that one. Okay. Now if I look at that, would you agree that that angle right there is that one? And this angle here is that one. What types of angles are they? Corresponding. So what should you say about them? They're equal. So 68 is equal to 8y plus 4. Subtract 4 from both sides. 64 is equal to 8y. You guys get y to be 8. Okay. So now x was 30, y is 8. Okay. Now I have to think about, well, okay, find 2z. Okay. And I might now have to bring back in that other transversal, maybe right there. Okay, but here's the thing. That was 90, right? That was 68 now, right? Okay, so if that's 68, that's got to be 68. There's a couple ways of thinking about this, but what do those two angles from chapter 1, when we do angle addition, what do those two have to add to? Jalen? Have to add to 90. If you got 68 of it already, then that means this little sliver here, that one right there, which is that one there, has to be 90 minus 68, right? Has to be 22 degrees. So do I have now an expression of 2z should be equal to 22? And z is 11. Okay. I like questions like that. Okay. I really like this one. Okay. So let's do this one. What's tomorrow? Okay. I really love this question. Really like this question. This one. So find x, y, and z in that one. Again, it's a situation where maybe you struggle looking at everything that's up there, right? Okay. And if you see this on like Math Excel or something like that, or then of course exam, and you got scrap paper in front of you, you're gonna have to draw pictures. So and it might be a good idea just not even to draw the whole thing right away. Just draw those two parallel lines. I'm gonna draw those over here. Okay. Would you agree that that is a transversal for this? So let's draw that transversal over here. Okay. Does this angle right there go right there? Okay. So what would go right here? X, right? What types of angles are X in that right angle? Corresponding. So X needs to be 90. Okay. Now, if you know that that's 90, there's some other stuff you can do here. If you know that's 90, what does that angle right there have to be? 90. And there's two reasons, right? It's a linear pair with X, but it's also the same side interior with that other right angle, right?
Yeah.
Okay. But we know that's 90. So we should be able to say those two angles, which we're using as angle addition, I could say 3y minus 11 plus maybe 4z plus 2 is equal to 90, right? Now what's wrong with that? Or what's the problem with that? Two variables, okay? So I either need to create another equation that has the same two variables or create an equation that solves for y or z individually. So I've kind of exhausted everything that I know about that picture with those lines. And you can start, if you'll put x up here, yeah, that makes sense, it works, but it doesn't really gain you any information, okay? So what I'm going to do is I'm going to look at a different transversal. So if I look at those parallel lines again, but now let's bring in that transversal, okay? This angle here, okay, would you agree that that angle there matches right there? Okay, and that's 3y minus 11. And this angle here is right there, right? So what can I say about those two angles? Alternate interior, so they need to be what to one another? Equal, congruent. 3y minus 11 is equal to y plus 19, right?
Yes.
2y equals 30. Y is 15. So now, once I came across, and this is something that happens quite a bit. I came across an equation that I knew to be true, but I was having trouble solving it. Still write this equation down, and we didn't erase it, we left it there, because the hope is, later on, I will find one of those variables, I'll find y, and be able to rewrite that equation as 3 times 15 now, or 45, minus 11, plus 4z plus 2, equals 90, and now does it make that problem a lot easier to solve for z? So 45 minus 11 is 34, plus 2 is 36. So we got 4z plus 36 is equal to 90. 4z is equal to 54 then. All right, now what's everybody want to do once they get 4z equal 54? Grab what? Grab the calculator. Don't. Do it this way. Write it that way. And now they both end in 4, right? So what do you know they at least divide by? 2. Okay? When they're both even, they should both be divisible by at least 2. So I'm going to take that 2 out and rewrite that as 27 over 2. Okay? And we're going to leave it that way. Okay? I don't want to write it as 13.5. Okay? Now, Math Excel. Okay? You just got to pay attention to the directions. Math Excel might say type in as a decimal. Okay? that's fine, but my hope is that you go through the process to get that blue answer first, okay? And then if you need to type it as a decimal, then take your calculator out and type it in your calculator. The reason I want you to do it this way is because eventually there's going to be some algebra, and it happens a lot in May, April, March, okay, when we start getting a lot of stuff under our belt and we're able to do a lot more geometry than we currently can. We're going to take that number and do something else with it. Say I take that number of 27 halves, and I want you to multiply that by 8. Well, that's pretty easy to do. If I multiply that by 8, those cancel, leaving me a 4, right? Okay? And then 27 times 4, well, 27 times 2 is 54, right? So 54 times 2 then would be the same thing as 27 times 4, so it gives me 108. That's a lot easier to do in my head or quickly with scratch work than saying 13.5 times 8. And going 8 times 5 is 0, carry the 4, gives me 8, carry the 2. Okay? And now I get 8 times 1 plus 2 is 10. I get 1080, but I got to remember, oh, there's one decimal place here, so move that decimal place to there, and I get the 108, right? Fraction, the use of fractions, so we can do other calculations so much more efficiently and quicker using the algebra rules that we learned last year. So do not rely on your calculator. And what happens a lot of times, people do rely on their calculator, and what we want to do is we want to take like 27 over 2 and we want to square or cube it or something like that later on. And because they haven't learned the fundamental algebra, they don't know how their calculator really works. They type it in incorrectly and get a wrong answer, but not know that it's wrong because they don't know the algebra that should have been done. Does that kind of make sense? So learning our algebra is going to be very, very important. So I want us to leave answers like that until otherwise told by